Alright, so this video is for Lab 1 of Chemistry 104, Introduction to the Chemistry Lab. And the procedure says, introduce yourself to your lab partner and get their contact information. And introduce yourself to the teams at your workbench. So you'll be working at student benches where 4 students can fit. Obviously right now we're social distancing and working from home remotely, so you could form groups on D2L and discuss with each other, but I guess for now consider me your lab partner. Consider sharing the reason that you're in this class. Each person will record their own data during the lab session. Even though you'd be working together with a lab partner, you'd be recording your own data. Work with your partner to inventory the lab drawer and identify the pieces that are within it. So the first day of lab, you would go through this document and verify that everything that's supposed to be in your lab drawer is in it. This is the contents of your lab drawer. So you should have 3 graduated cylinders. So these are graduated cylinders. You have a 100 mil, 50 mil, and 10 mil graduated cylinder. Put that back here. Next is beakers. These are all nested inside each other. So you'll have a 600 ml beaker, 400 ml beaker, 250 ml beaker, 100 ml beaker, and then 2 small 50 ml beakers, which are very tiny. Erlenmeyer flasks, you will have a 250 and a 125 ml Erlenmeyer flask. You can see that. Put these off to the side. And then you'll have your small scale reactions items. So you'll have a plastic reaction surface sheet, which is just a plastic screen protector for your page within your lab that you would be doing small experiments on. And then a 24 well plate, which looks like this. You would just drop different liquids in there and see how the chemicals react. Other laboratory materials that are within your lab drawer are a funnel, which looks like this, a glass stir rod, which looks like this, a watch glass, which looks like this, and a small stir bar. This is like the smallest it gets. Well, not really, but it's pretty small. Other materials that are in your lab drawer are a metric ruler, should be metal, scissors, and a grease pencil, which is also called a China marker. For this section, you will use a 10 ml pipette, a pipette pump, a 50 ml graduated cylinder, and 2 50 ml beakers. You'll want to study each tool's calibration markings, comparing the width and length, and looking for the digit of uncertainty for each tool. So I will try to include close-up pictures as well. So this is the beaker. the graduated cylinder. This is the pipette. And this is your ruler. Half fill one of the 50 ml beakers with deionized water from the squeeze bottle on your bench. So that's this, and I already filled it with some DI water. This beaker is only a reservoir to take water out of. Do not take any measurements with this beaker. Next, measure out slightly more than 10 mils of water using the 10 mil pipette and pump. So you'll attach the pipette, pump, and then to draw up water, you just use that. Slightly more than 10. Let's see if I can get a good picture. Well, I'll try to include pictures as well, but read the volume from the calibration marks on the pipette. Record your reading on the data sheet using the correct number of digits. Dispense the water from the pipette into a 50 ml graduated cylinder. So that's this. And then carefully record the water volume from the calibration marks on your graduated cylinder, and then record your reading on the data sheet using the correct number of digits. Note, this is a separate measurement from the measurement that you made with the pipette. The volume may not be the same, and the number of reported digits will certainly be different. So step 5 is carefully pour all the water into the second empty 50 ml beaker, and be sure the beaker has calibration markings. So we'll pour it into our second beaker. Read and record the water volume in the beaker on the data sheet using the correct number of digits. Look for the digit of uncertainty and discuss with your lab partner. Note, this measurement will not be identical to the other measurements that you made with either of the two previous tools. So now we're done with that part of the lab, and we'll move on to mass measurements.